Hey guys, hello everyone and welcome to the channel and welcome to another video of this aptitude series. In the previous video, we have discussed that how to do questions based upon geometry related things. Today in this video, I'm going to tell you that how you can do questions which are based on graphs and equation. Now, on the basis of graph, there are two types of question. One is in which you will be given with some equations and certain condition. Okay, so either equation or certain condition is given to you, and based upon that they are going to ask that what type of graph fits that particular condition. Okay, it might, like, the majority of the things are related with speed and time related things. Also some equation might be given, and based upon that they will ask you to predict the graph. So that is one type of question. So in this type of question you have to actually predict the graph. Okay, the second type of question is called as data interpretation. So that we will do in some other video. So in that, what happens that they will give you some data in the form of graph or bar graph or pie chart or any form, and they will ask you to take out the information from there and tell them what is the correct information. So that data interpretation we will do in some other video, but these two types of questions are very simple to do, and it's one of the thing which you should search for in the question paper, that whenever you get a question paper, graphs are easily visible. So see the graph question and just jump to try to solve it. Okay, and today I'm going to give you some trick also how you can do these graphs related question. These are super simple to attempt. You just have to apply some logical understanding of the condition if it is given, and if the equation is given, then the thing become much easier for you. Okay, so that's what we are going to do in this video. So let's now continue with the video. Okay, so this question was asked in CSI 2021, the recent exam. It says that a vessel is partially filled with water. More water is added to it at the rate directly proportional to time. So they have given you an equation here. The equation is that dV by dt is proportional to t. Which of the following graph depicts correctly the variation of the total volume V and the time? Now, these things are very easy to do. First of all, you need to understand, you need to just apply some logical understanding to approach it first of all. So they have said that the vessel is partially filled with water. That means if, let's say, this is the vessel in which water is being kept, so initially it is somewhat filled, or some partial filling is there, or somewhat it is filled with water. So that means initially it has some amount of volume in it. Okay, so you don't have to, like, initially there is no zero volume, or the volume is not starting from zero itself. There is some amount of volume is given to you. So let's call it as V naught. So that means if you are going to plot a graph in which you are going to plot volume versus time, so when the time has not started, that means when you have not started filling it, still the volume, there is some volume in it, or there is some water in it. So that's why graph is not going to start from this point, that is 0, but it will start with some positive value of volume, because initially you have some water in it. So that's clearly going to cancel out two options, that is option number 1 and option number 4. Now you can only stick with two options, that is option number 3 and option number 2. Now let's see what you can do next. So since we have to plot a graph between volume and time, but we are given with the equation which is change in volume and change in time, so to do this type of question, the simple way is to integrate. Okay, because we have to remove this differentiation. So reverse of differentiation is integration. Just like reverse of addition is subtraction, reverse of multiplication is division, in the same way reverse of differentiation is called integration. So that's what we will do. So we all know that if we remove proportionality, we will be having some constant. So let's say we are adding some constant kt. Okay, so this k has no significance over here. It is just a proportionality constant. Next is what we will do is we will keep dv this side, and we will take this dt to the other side. So this is simply like you have done lot of these type of integration when you have studied kinetics, chemical kinetics. Now integrate on both the sides. So on integration, you all know that integration of dv will be v, and integration of t, so k will not get integrated, integration of t will be t square by 2. So now you will find out that this equation is not a linear equation, it's not a straight line plot, because you know, a straight line, like a straight line graph, you all should know this, okay, that y is equals to mx plus c. That means here everything has power 1. That's why it is called linear equation. So everything has power 1. Y is also having power 1, x is also having power 1. Then only it will become a straight line. So among option 2 and 3, option 3 is a straight line. So this would have been our correct answer if the relationship between volume and time will get a straight, or it's like a linear relation. That's not happening, right? The relationship is not linear. You can see it's a quadratic relation, or called as parabolic relation. So because of this, your correct answer is option number 2. You know basic mathematics, if you have studied maths till your class 10th or a little bit more, then you can easily do it. Otherwise, you are seeing these type of derivation in your like in kinetics and all. So based upon that knowledge, you can do these type of question. Another way of solving it is, after getting till here, you can just make a table or make a chart, and there you can basically write down the value of volume and the value of time, put the different values of time and write different values of volume, and see how, like, whether it is following a straight line or not. You will find out that it will not form a straight line. Okay, so that is another way of approaching it, but I find the previous method or the first method much more easier and much more straightforward, and it's more accurate as well. Now let's go to the next question. All right, let's look upon this question. This was asked in CSIR 2020 exam. In 2020 we only had one exam. So yeah, which of the following plots represents the function y is equals to x? Now see how clearly they have played with you. They have given you y is equals to x, but the graphs are, all the graphs are y versus 1 by x. Okay, now many people just thought of it as y is equals to x and they just gave option number C as correct, but that's what mistake was done. Okay, and you don't have to do that. Y is equals to x means what? That means whatever value of y is there, same value of x will be there. If y is 1, x is also 1. If y is 2, x is also 2. If y is 3, x is also 3. So that is clear, right? Now, but the graphs are in like y versus 1 by x. So we can say that the function which we have is 1 by x. So to do this, what you have to do? You have to simply make a table, okay, in which you have to put the values of y and the values of 1 by x which you are going to get, and clearly the whatever value of y you will put, same value of x you have to put over here, and whatever after solving, whatever 1 by x you are getting, that you have to write down. For example, if I put y is equals to 0, okay, so what will be this whole thing? X also have to put 0 because of this condition. If I put x is equals to 0, this becomes 1 by 0 or infinity, right? 1 by 0 is infinity. Now if I put y is equals to 1, what will happen to x? X also have to put 1, so that becomes 1 by 1 or is equals to 1, right? Similarly, if I put y is equals to 2, so this 1 by x will become like 1 by 2, because in the place of x I have to put 2, and this becomes 0.5. Okay, so yeah, this becomes this becomes 0.5. So if I take y is equals to 4, 5, any value, if I take, let's say if I take y is equals to 3, this becomes 1 by 3, which is equals to 0.33, right? So what you can see is, as you are increasing the value of y, your x is decreasing. Your x, when y is 0, that means at this place your x is very high, that is at infinite. And when you are increasing the y, let's say this is 0, this is, let's say, 1, when you are making it 1, you are getting 1 by x also as 1. Okay, when you are taking it at 2, so in that case 1 by x is decreasing. See, it's coming to 1.5 or something. So that means when you are increasing y, your 1 by x is decreasing, right? That's what you can say. So if y increases, 1 by x decreases. That's what I can say. So there are two graphs in which on increasing the value of y, 1 by x is decreasing, and these are graph number 1 and 2. And the other graphs like C cannot be the answer, because here on increasing y, 1 by x is also increasing. So it's a linear relationship, which is not over here. Over here the y is constant and the x, 1 by x is changing, so that also is not going to happen. The only graph which validates this, because you see that when you are putting y is equals to 0, that means over here 1 by x is very high. 1 by x values are over here, right? So you will get very high value, that is at infinite. So that's coming over here. And if you put y is equals to infinite, let's say, In that case 1 by x will be 1 by infinite, and that's becomes 0. That means if you take y very high over there, like very high at infinity, so your 1 by x will become very small and it reaches to 0. So that's why graph number 1 is your correct graph for this. So that's how you have to play with the equations given to you, and you have to, if you are getting confused, just put the values and solve. That is the easiest way to do these type of questions. Okay, so it was very simple, little confusing, but very simple question. Okay, let's see this question. It was asked in CSIR December 2019 Assam and Meghalaya region question paper. Now if you see, this is a condition based graph question where some condition they are giving. It says which of the following graph correctly shows the growth of sapling to a mature tree. Now you all know that if I plant a sapling, which is a small plant, and if I plant it out, with time what will happen? It will grow bigger, right? It will grow bigger into a tree, and at the end what will happen? That it will become a big tree, right? That's what we all know, right? Now what happens that if you look upon the growth of this, you have to now understand that with time what will happen to the height of this sapling. So of course it will increase, but whether this height is going to increase for infinite number of time. So let's read about the graph one by one. First graph says that with time the height is increasing, fine, but with time the height keeps on increasing. It goes till infinity. Like if you keep on increasing the time, the height is also going to increase infinitely, but it does not happen, right? The sapling grows into a tree, and when the tree becomes mature, after that it stops, or its height does not increase as much, but its leaves, fruits, all the other things are grown there, right? So the tree does not keeps on becoming bigger and bigger. Only the other like the branches, leaves, fruits, those actually are grown. So that means the height first of all increases, but then it becomes a constant. It does not increase as much. So first graph cannot be answered because here the height is increasing throughout the time. That cannot happen. Second says that the height increases initially, that's fine, but after reaching certain time height decreases. Whether it happens to the mature plant, does it becomes shorter after some time? No, it does not happens like that, right? So second option is also incorrect. That means the height does not decreases for the plant. Third option or third graph says that the height slowly increases. Initially, see, when the sapling is small, it does not quickly grows up. It takes time to grow, right? And there is a growing phase where it grows fastly, and then it becomes a mature tree, and then it stops growing, or its height does not increase that much. So you can see this is the sapling region, this is the growing region, and this is the region where it has become mature plant, and now its height is not increasing much. So this is actually the correct answer. Let's read the fourth one also. Fourth one says, okay, the sapling is not growing in, and like within a short span of time it increases to a very good height, and then it dies, or it does not dies, means its height becomes 0. So does it happen that the mature plant or the mature tree is going to height is going to become 0? You might argue that the plant plant dies or something, but we are not looking for the death of the plant. We only have to look from the sapling to the mature tree. Okay, so does it happen that when the mature tree is formed its height is 0? It does not happen, right? So that's option 4th is incorrect. The correct option is option number 3. So these like condition based graphs are very easy. You just have to apply logical understanding and you can simply do these type of questions. Let's see one more question. Okay, so this was asked in CSI June 2019, and it says velocity time curve of a body is given in the diagram below. Okay, so this is velocity and time curve. The diagram showing the acceleration of this body as a function of time is. Now you have to understand few things. Okay, so if you are given with a velocity time graph, okay, if you are given with velocity time graph, so what you have to understand, that the slope of this graph, okay, the slope of this particular graph gives acceleration. Okay, slope of this graph gives acceleration, whereas area under the curve it gives you distance or displacement. Okay, distance or displacement. If it is velocity, it will give displacement. If it is a speed, it gives you distance. So these two things you have to understand. This is basic physics and you all should know. Why it happens, I'll explain you also, because the slope of this graph is going to be like dv by dt, right? The change in velocity versus change in time, and this is acceleration, right? So that's why I said that slope gives you acceleration. And in order to find out area, it will be like this into this, means whatever, let's say if we have a rectangle like this, so the area will be what? This will be like length into width, right? If it forms a rectangle, let's say, so the area will be like length into width. So in that case, it will be like velocity multiplied by time. And you know, speed is equals to velocity or distance or displacement is equals to velocity into time. So that's why I said ki area is equals to displacement or distance. Okay, so that's why it happens. Now here you have to see that the velocity time curve of a body is given in diagram below. What is happening? See, from let's make them as points. Okay, so let's say this is point O, this is point A, this is point B, and this is point C. What's happening between point O and A? Between point O and A, the body is accelerating, okay, and the slope is becoming positive. So that means there is a certain acceleration. And since this graph is, or this slope is linear, or you can say it's a constant increase, so that's why we will say that the acceleration is constant. So what we will say, that between OA, what's happening? There is a constant acceleration. All right. Now what's happening between A and B? The velocity is constant. If the velocity is constant, and understand that the slope is calculated as tan theta. Okay, slope can be calculated as tan of that theta. So this is nothing but tan of theta. So if you see over here, that is tan 45, and tan 45 is 1. So I'm just telling to the maths people how you can do with the help of trigonometry also. But between A and B, what's happening is the angle is 0, right? It's not increasing. The velocity is constant. So if the velocity is constant, there is no acceleration. So between AB, what I will say, that there is no acceleration, or the acceleration becomes 0, or there is no acceleration. What happens between B and C? Now the velocity is decreasing. See, velocity first increased and then decreased. So this is called deceleration, or decrease in acceleration. So between B and C, what's happening? That there is decrease. And what type of decrease it is? It's again a constant decrease, right? So I will say it's a constant decrease in acceleration. Okay, or you will say that there is a constant, or there is a decrease, and the decrease is constant. Okay, now that's what we have to plot. Okay, now let's look upon graph number 1. What it says that you have a positive value of acceleration. Okay, so we also call it as negative acceleration. Okay, this thing, this constant decrease in acceleration, is also called as negative acceleration, or is also called as deceleration. These are all given in physics. So yeah. Okay, so what's graph number 1 says? It says that between point O and A, you are having an acceleration. Okay, fine. Yahan tak it is correct. Then between point A and B, the acceleration is 0. Again, it is correct. We are not having any acceleration, so acceleration is 0. And between point B and C, you are again getting a positive acceleration. That's not true, because here we are getting a negative acceleration. So option number A is incorrect. Let's look upon graph number 2. Graph number 2 says that you are having a positive acceleration between point A and B. O and A. That's correct. Between point A and B, now you have 0 acceleration, because see, the graph reads 0 here in the acceleration. So again correct. And between point B and C, okay, between region B and C, you are getting now a negative acceleration. That's totally correct what we are observing. Let's look upon option number C. Option number 3 says that between point O and A, there is a increase in acceleration. Does the acceleration increases over here? No, acceleration is constant over here. Okay, so acceleration does not increases in this region. That's why this option is incorrect. And option number D though is totally incorrect, because this is nothing but the same graph being plotted again. That's totally incorrect. So that's why correct option is option number 2. So this is how you have to do the questions which are based upon graph and equation. You just need a little bit of understanding of the things, and then you can simply apply them to solve these questions. I'll give you one question as a homework over here. You can see it's a question which was asked in CSIR June 2018 exam. It says movement of a car with respect to time is given below. All right. average speed of the car you have to find out. So to do this type of question, you first of all need to find out total distance. Okay, you have to find out total distance, and then you have to find out total time. You need to find out both these things, then only you can find out average speed is equals to total distance divided by total time. Alright, so while editing the video, I just realized that I should have given solution of this question as well, because like just for the sake of your understanding. Okay, so just that's why I'm just adding this solution for this particular question. In case if you have already solved it, it's very good. In case if you were not able to do it, here's the solution of it. Okay, so how to do this? First of all, it says that as I told you earlier, that you basically have to find out average speed, and average speed is nothing but is equals to total distance traveled divided by total time which is being taken. All right, so that's what our motive is. We want to calculate total distance first of all, and as I said that the distance is nothing but area under curve or area under the graph of speed and time graph. Okay, so that gives you distance. All right, so we just have to calculate the distance of this. So distance is nothing but like distance is area under speed time graph. Okay, speed time graph. So now let's try to do it. So I'll just zoom this up a little bit. So what you can do to do this is you have to divide this whole figure in squares and rectangles and triangles. Okay, just like if you join this line, so this whole thing becomes a triangle, right? It becomes a triangle. Similarly, if you join this, it becomes a rectangle. All right, then if you join like if you join a line like this, all right, and then if you join like this, so this becomes a rectangle and a triangle. If you want to do that, or you can consider this whole thing as a trapezium as well. So now you have to apply a formula for areas of these figures. So first of all, let's divide this. So this is going to be divided something like this, right? So yeah, it will be divided like this. So we have divided it in this way. So let's call it as the area number 1, this is area number 2, this is area number 3, area number 4, area number 5, 6 and 7. Okay, so there are 7 sections now. Now area first is actually a triangle. Area of a triangle, you all know, is half base into height. The base is of 1 unit because from 0 to 1 it is 1. The base is 1 unit and height is 10 units because you can see in the graph it reads 10. So it's of 10 units, right? The second area is of, it's a rectangle. Length of this is 1 and width of this is 10. So 1 into 10, that's what it will be. Now the third region is actually a trapezium. Now for trapezium, if you don't know, so area, I'll write down here that area of trapezium, this is given by this formula, half sum of parallel side and multiplied by the distance between them. Okay, multiplied by the height or the distance between them. So that's how you calculate the area of trapezium. Now any trapezium will be like this. Okay, something like this. So you will be having two parallel sides, so sum of those parallel side and the height of them. Okay, now because this is half, like the trapezium over here is in this form, so that means ki these are two parallel sides and the height is this distance itself. So now we can use that to calculate area of the third section. The third section area can be simply calculated as, again, like half two parallel side is of unit 10 and of unit 30, because this height is 30, this is 10. So 10 plus 30 and multiplied by their height. Height is between 2 and 3, so the height is 1. All right. Similarly, fourth region is again a trapezium. It's like already going to be given as half sum of parallel sides. So this is 30, this is 40. So 30 plus 40 and into the height. Height is again 4 minus 3 is equals to 1. So again got 1. This side also will give you the same thing, half 30 plus 40 and into height is 5 minus 4, that is 1. Now coming to this region number 6, this is a rectangle. Now this will be given by length into width. The length is 30, width is 6 minus 5, that is 1. So 30 into 1. and at the end we have section 7th or the 7th region. Over here this is a triangle, so it will be given as half. Base is let's say 1 and height is actually 30. So that's how we have got all the 7 sections. Now I will just write down the values which we will get. So from here I will get 5 for this. For this I will get 10. For the region number third, it is 10 plus 30, that is 40, divided by 2 is 20. Now coming to the fourth section, 30 plus 40 is 70, divided by 2 is 35. Similarly for this section we will get 35 because both these are same values. This is going to give me 30 and this is going to give me 15. So the total distance, if I have to calculate, the total distance or the area will be like 5 plus 10 plus 20 plus 35 plus 35 plus 30 plus 15. So 1 2 3 4 5 6 7, yeah. So if I add all of them I will get 150. So my total distance traveled for this whole graph is going to be 150. I now have to calculate average speed. Simply I will do that. So average speed is equals to total distance, that is 150. What is the total time? You can see from 0 to 7 hours we have covered. So divided by 7, if you divide this will be like 21.43 kilometers per hour. So that is going to be your answer for this particular question, option number 4. So this was as easy as it looks like. So anywhere, wherever you are given with a graph where you are like asked to find out average speed or something, always first of all calculate total distance and then calculate the average speed. So this is how it will be done. This section was added later on while I recorded the earlier sections of this video. So that's all for this video. Thank you so much for watching, and I will see you in the next video, in the next part of this particular series. Meanwhile, I will also start a series of new questions on chemistry as well. So do let me know if you want questions from, like, new questions from chemistry, or if you want previous year's questions. Do let me know in the comment section. I'll look upon that, and based upon your responses I'll start a series. So that's it from my side. Thank you so much for watching. I will see you in the next one. Till then, have a great day. Bye bye. Take care. Hey guys, so I teach live on Unacademy Plus platform. Here I teach for the CSI UGC NET category, and you can follow me over here for regular classes. You can access my free classes as well as my paid classes on this particular platform. The classes which are free, you can get that under the section of special classes, whereas in order to access my paid classes, paid live classes, you have to take Unacademy Plus subscription. So do make sure that you take the Unacademy Plus subscription to access all my paid classes, which are quite organized. The whole syllabus is being completed over there, and the classes are quite regular over there. So make sure that you take Unacademy Plus subscription by using my referral code, that is N_Huda. That's it for this. Thank you so much.